Thank you, Watson. So this talk is all about the Apollo Graph Manager. We're going to start off with a basic introduction into what it is, and then we're going to dive into a demo for the rest of the time. So I'm Evans. I'm a core developer on the Apollo platform. And the reason I'm so excited to talk to you today is because for the past year and a half, I've been developing a GraphQL application. It's the Graph Manager. And the reason that I'm pumped is because I've found that over that year and a half, we've developed so many good workflows that I'm excited to share with you today. And over that year and a half, I've realized something interesting, is that in order to do GraphQL right and to have a data graph, we need to have a data graph platform. Let's dig into what exactly a data graph platform is. Well, it starts with a GraphQL layer. So it starts with the producer of a data graph. That's oftentimes Apollo Server. We use Apollo Server internally, and we delegate to a bunch of different microservices separated based on concerns like schemas and operations. We also have consumers. So oftentimes a web client. You may have an iOS client and an Android client. I'm excited for when those are going to come to Apollo. For now, we have a CLI and a VS Code integration. And those end up being native clients. So in addition to the producer and the consumer of the GraphQL API, we have a Graph Manager. And what the Graph Manager does is provide solutions to workflows that are necessary for GraphQL development. During the demo, we're going to focus on a couple different key workflows, including schema tracking, performance insights, protected schema changes, and a little bit about the client identification. In order to support these workflows, we get a bunch of data from a variety of locations, including continuous integration and the Apollo Server usage metrics. And these metrics are quite useful in the Graph Manager, and they're even more useful outside of the Graph Manager in integrations, such as the VS Code integration that we're going to dive into today. So let's jump right into a demo. I think that's enough of that. What we're going to use for a demo is the Space Explorer app. So this is an Apollo project built on top of a data graph. And this ends up being our full stack tutorial. So you're able to follow along with it later. I made some additions for the sake of this demo, but for the majority of it, it's the same. So this is a data graph that delegates to a REST API, the SpaceX API. And we're able to click on different missions. We're able to add things to our cart. Our cart is a local state. We're going to hear cache. We're going to hear more about that in Danielle's talk. And then inside of our cart, we're able to book our trips. And then eventually, when book trips shows up, we can click on that and cancel them. For the demo in the code portion of the client side, we're going to focus on this experience. So keep that in mind. So now that we've seen the client side of the application in the front end, we also have a server running. In this case, it's deployed to both Heroku and locally for the demo. And that exposes a data graph. So with that data graph, we have a data graph manager. So this is Engine. Many of you know it as Engine. Today, we're rebranding it as the Graph Manager. And this is the dashboard to the manager. So right away, we jump in and we see the Schema Explorer, which provides us an easy and intuitive entry point into understanding what fields we have available. And if we have descriptions, we can see those. Now, this represents the current state of our production schema. And there's also a history of that schema. So when new deploys are pushed and the schema changes, we keep track of a changelog. And this is quite useful if I want to understand who's changed what, who I need to ping about what changed. So for example, here, Danielle made a change that added the cancel trip mutation. And I might ask her, why? Cool. So that's the schema registry side of things. In addition to the schema itself, we also have usage metrics. may have to refresh this page to see them. Maybe the internet's not working. I hope that's not the case. So we have, let's see, that's odd. Okay, well, so we have usage metrics for each field, and we're going to dive into what exactly that means. All's not lost because we have usage metrics per field and that's captured from our structured logs that come from Apollo server. Let's dive into how that usage data is useful in your day-to-day development workflow. So this is that's the server. Is this big enough for y'all? So here we have the book trips component. So this was that component on the right side of the screen that gave you the list of all of the trips that you booked. And here we see in our development environment the usage statistics for your query, and you're able to get this as you write a query. So the reason this is so valuable is as a front-end or full-stack developer, I oftentimes am not thinking too hard about performance when I'm writing my queries. And then I might see something expensive like the trips. So this is coming from the SpaceX API. It might be slow. So what that prompts me to do is think about my loading states. And I can create my app around those performance characteristics, or even if I need to tell somebody about those performance characteristics to give a user a certain experience, I can go to a backend developer and talk to them. I might go to the schema history in order to determine who's responsible for that field. Let's dive into the cart contents. So here we have a mutation component with some cache updates. So oftentimes I've found that the front-end requirements change, and I need to add some more data to a component or have a different experience in the UI. I need to have some optimistic updates. So in this case, our book trips returns a simple Boolean. Well, I want something more. I want to update my cache on the front end so that I immediately get an update in my book trips. So as a full-stack developer, I can jump into the server and do that. So here, we have a mutation. So this is Apollo server. This is schema definition language. And I'm going to update this mutation in place. So I'm going to use a trip update response. This is a really common best practice for mutations. So instead of returning a Boolean, we want to return an object that allows us to provide some more data, as well as maybe provide some more errors, maybe an error code, depending on the complexity of your UI or your data graph consumer. So I'm also going to change the book trips mutation result. Awesome. So now that I've made an update to the schema and to the resolver, I'm going to create a commit and push that up to my remote. I'm also going to make a pull request. And this pull request will kick off a continuous. That's unexpected. You don't see that very often. I'm glad we recorded that. 4 nines is really great. So what this does is it kicks off a deploy, a CI job in Circle. So we had to set that up and connect that with the graph manager. And what it does is it runs a service check. So this is the entry point to schema validation. It's Apollo service check. And what the service check does is takes your changes to a schema. So in this case, we changed Boolean to trip update response. And it compares that against the traffic that's running against your server or your data graph. And if there are any operations that update those changes break, then we'll get a failed build. So here I see that I've failed my build. And I don't really know why. Not really aware of any consumers except myself, or not even aware of consumers because I'm trying to keep my schema agile. So I'm going to click in for more details. And what I see here is that it turns out there's a lot more clients than I expected. There's an iOS client, there's an Android client. And those all use the field pretty intensely. So we can't make this change, otherwise we're going to break these clients. If I don't really know why, I can look into the documentation and understand that a Boolean is a scalar, so it doesn't require a selection set, whereas a trip update response requires a selection set. This is inspired by one of the internal use cases we found for supporting the CLI that I can talk about more if a build fails. But what we're going to do is we're going to do something called field rollover instead of an in-place update. So this is another best practice for making in-place updates that might be breaking. So what I'm going to do is I'm going to create a new mutation with a different name that returns trip update response, and then I'm going to deprecate. So what that looks like is creating a new mutation. Then I'm going to update book trips to return the same values that it used to. And then I'm going to deprecate and provide a good reason why. So what a deprecation does is it's enabled by a deprecated OK. So what a deprecated directive does is it tells the clients that you should no longer use this field. So in GraphQL Playground and Graphical, it won't show up anymore so that we won't use it. The reason and what we have here is shown to the client developer. So we want to make that reasonable. Then I also have to update the mutation to include the new book trips with response. And then I'm going to return the book trips mutation to its original functionality. And I'm running prettier, so hopefully this stuff all works. Cool. I'm going to make another commit. And I'm going to push that up. So we can go back to our Git, and we see that we have another commit running with a CI job. So fingers crossed it works, and we get a passing change. So as I said, this is field rollover. This is a super common way to make a perceived breaking change to the graph and augment your functionality in a safe way. So our service check passes, which is awesome. It's always nice to know that we have that security, because I've had the experience of making an inadvertent change and not feeling too good about it. So let's squash and merge this. What that does is it'll kick off a deploy, and what we're waiting on there is the service to be deployed, and then we call service push, which will update our schema history as well as our latest Schema Explorer. While we wait on that, we can look into exactly what changed to make sure that we actually made the change we want. Ideally, you would do this before the squash, but for the sake of the demo, I squashed first. So we see book trips first, and then we also see book trips with response. That's awesome. So now we can look into our schema history and see that we have the new schema change with the deprecation and the field added. And I think this is really where the Explorer shines, is when we have to do this. refresh the page in order to get the new schema, and let's go. So we see the deprecated, and we see the new mutation. Where it really shines is we can go over to the deprecations tab and see exactly what fields have been deprecated, and we can see how long, or rather, how many requests are being done against that field. So there are a couple, we've done this many times, and there are many deprecated fields in our data graph internally. And so I come to this page a lot in order to determine if I can deprecate something, how many people are on which version of the CLI, and it really helps me have confidence that I can make changes to the data graph to keep it agile and make sure that, like, when something can be removed, I can remove it so that I'm not dealing with tech debt and cruft in my code base. Awesome. So that's the server side of deprecations. Let's take a look at the client side of deprecations. I'll have to remember which desktop I'm on. So let's refresh the schema. And what we see here is that we get a warning message for each deprecated field in our application. This is an Apollo project that's set up and wired in with the Apollo extension. Danielle's going to talk about that more, so stay tuned. And so we know that we need to do something else. We need to use book trips with response. That's awesome. That doesn't really tell me why. Like, as a client developer, I'd be like, why? So I can go to the schema history tab and say, who deprecated this field? And then I can go talk to them if there's some tribal knowledge that I need to retrieve. Awesome. I always like to see the application work, so I'm going to pull out my stashed changes, which will this uses the new launches, and then we do some cache updates to our local state here, and we can look into what exactly experience that gives us on the front end. So when we add something to our cart, and then we'll book it. So immediately when we see the bon voyage, we see our cart update. So that's the power of an optimistic update and the power of changing our data requirements over time in a safe manner. So what we've seen here is the Apollo platform, and this is just a taste of the Apollo platform. We've seen schema change control, we've seen performance insights, protected schema changes, a little bit of client identification, especially with the schema validation and the change that we needed to make, and that gives us an information about who we need to talk to about those deprecated fields. And we've heard a lot about federation, so I'm sure you all are wondering how this stuff works with federation. I was too, to be honest. I was like, I don't know. So we can go over to our, luckily this is a demo, so I've prepped a federated variant of our schema. So we can hop over to our federated variant and see that to the user, we have the same schema. And to our VS Code integration, we have the same sort of, slightly fewer requests because it's a new service. But it's completely transparent to the client and the consumer in the VS Code integration. What's different is that internally, we know that we have different services. So all of these different services, we see the extend launch, so that comes from the launch service. We know that we have different services that all provide data to the API. And so that's great. That's huge. We compose and at build time are able to create a schema that is transparent to the consumer. There's also a lot of complexity in here. For each different service, presumably a different team is working on each one. So they need to be worked on individually in isolation. So let's jump over to our user or accounts schema and determine how this works as a individual developer. I know nothing about the rockets or the launches. All I know is that I want to change login to Boolean because I'm an anarchist. And then let's hop over to, like, normally this would be done in CI. I think it's interesting to illustrate it as a command run from your CLI, or my terminal. And so this should be not users, this should be accounts. And we can run service check. The only thing that changes is we add a service name that corresponds to the individual service that I'm running. So the beauty of this is you can run these in separate CI pipelines so that your teams can be completely isolated from each other. Is this big enough for y'all? Cool. So let's run it, moment of truth. So we again see that we're able to run this in isolation and see the same sort of breaking change. And I can solve this on my own. And there's something really special happening here. When a service check happens, we're composing the changes to your current service with the rest of your production service. So what that means is that there's only one service that's being modified, and you only care about your individual service because we commit atomically. So presumably your production is static, and you can add to it, and that happens one at a time over and over. And we see here that we've broken clients again. So that's with the federated metrics that James mentioned. So that's the Apollo platform. We're really excited about it, and thank you.